How simplicity turned out to be an illusion. For a long time, simplicity felt like truth. The fewer the rules, the deeper the understanding. The cleaner the explanation, the closer we were to reality. This belief shaped how science searched for answers. Strip away details. Reduce complexity. Find the smallest set of laws beneath everything else. The universe, it was assumed, must be simple at its core. Complicated behavior was just surface noise. Scientists operated under the conviction that nature's deepest principles would be elegant and minimal. This aesthetic preference for simplicity was not arbitrary. It had proven extraordinarily productive throughout scientific history. To understand why this assumption matters today, we have to return to the age of reduction, when breaking systems into parts worked astonishingly well. Planets reduced to equations, motion reduced to forces, matter reduced to atoms. Each success reinforced the idea that beneath complexity lay elegance. Newton's laws compressed celestial and terrestrial motion into concise statements. Chemistry revealed that countless substances emerged from a relatively small periodic table. Each breakthrough demonstrated that apparent complexity could be understood through simpler underlying principles. And for a while it worked beautifully. The universe seemed cooperative. Phenomena that looked messy collapsed into clean laws. Prediction replaced mystery. Control replaced awe. Simplicity felt like progress itself. Maxwell's equations unified electricity and magnetism. Statistical mechanics explained gas behavior with simple molecular assumptions. Each generation found that complex descriptions could be simplified and made more fundamental. This trajectory seemed to point toward ultimate simplicity. But slowly, something strange happened. The more physics reduced, the more complexity reappeared. Not as error, but as necessity. New particles multiplied. Interactions branched. Rules required exceptions. Explanations grew longer instead of shorter. The atom split into electrons, protons, and neutrons. Those revealed quarks, gluons, neutrinos, and expanding zoo particles. Each layer exposed not a simpler foundation, but a more intricate one. At first, this was treated as a temporary inconvenience. Surely a deeper layer would restore simplicity. Surely one final theory would sweep away the clutter and reveal the clean structure beneath it all. Physicists maintained faith that the proliferation of particles was transitional. String theory promised unification. Grand unified theories sought to merge fundamental interactions. The complexity was interpreted as a sign that the ultimate layer had not yet been reached. But every deeper attempt produced the same pattern. Reduction removed surface detail, only to expose hidden structure underneath. What looked simple from afar became crowded up close. Reality refused to collapse into a neat core. String theory introduced vast landscapes of vacuum states. Attempts to derive particle masses encountered irreducible complexity. Instead of converging toward simplicity, physics discovered that complexity persisted all the way down. This was the first sign that simplicity itself might be an illusion, not a destination, but a perspective, a feature of scale, not of truth. What appeared simple depended on how closely you looked and what you chose to ignore. At large scales, averaging over microscopic details made behavior predictable. But this simplicity was statistical, emergent from complex underlying systems. And once that possibility emerged, physics faced an uncomfortable question. What if the universe is not simple at the bottom at all? What if complexity is not something to eliminate, but something built in from the start? This challenged centuries of intuition. It suggested the reductionist program might have fundamental limits, that there might be no final minimal set of rules from which everything else derived. At first, physicists responded by doubling down. More reduction, more unification. If complexity persisted, it must be because the right perspective had not been found yet. History encouraged that faith. Simpler explanations had always eventually won. Newton unified terrestrial and celestial motion. Maxwell unified electricity and magnetism. Einstein unified space and time. Each unification suggested the next was possible. But as theories advanced, the complexity refused to vanish. Instead, it organized. New symmetries appeared. New layers of interaction emerged. The deeper the theory, the richer the structure became. Quantum field theory revealed intricate particle interactions. Gauge theories introduced sophisticated mathematical structures. Supersymmetry proposed to simplify physics, doubled the particle count. Rather than finding a simple core, physics discovered fundamental reality, exhibited elaborate organization. This created a conflict with expectation. Simplicity was supposed to be fundamental. Complexity was supposed to be emergent. But the universe seemed to reverse that relationship. Simplicity appeared only when many details were averaged together. Complexity was present at the foundations. This inversion was conceptually jarring. Macroscopic simplicity emerged from microscopic complexity through statistical averaging. Thermodynamics emerged from chaotic molecular motion. Fluid flow emerged from discrete atomic interactions. As experiments pushed into higher energies and smaller scales, this pattern became unavoidable. Each new regime introduced new behavior, new constants, new parameters that could not be derived from simpler ones. The dream of a single, minimal rulebook began to fade. Particle accelerators revealed new particles rather than confirming simple structure. Cosmological observations introduced dark matter and dark energy. The inventory expanded rather than contracted. This was not chaos. The complexity followed rules. But those rules did not compress neatly. They layered. They branched. They interacted in ways that resisted collapse into a single explanation. The universe exhibited order without minimalism. Different scales required different descriptions. Unity was achieved through understanding how complex descriptions fit together, not through reduction to simplicity. Emotionally, this was frustrating. Science thrives on compression. Fewer laws mean deeper understanding. But the universe was offering understanding without compression, explanation without elegance. Scientists could predict behavior and map structure, but could not compress that understanding into simple formulas. Progress was being made, but it did not converge toward simplicity. By this point, simplicity no longer looked like truth. It looked like a human preference, a desire imposed on reality rather than discovered within it. And physics was being forced to confront that mismatch. The preference of simplicity was revealed as anthropocentric, a feature of how human minds organize information rather than a property of nature itself. The universe was not designed for human cognitive convenience. The conflict deepened when physicists realized this was not a temporary stage. Complexity was not something waiting to be explained away. It was stable, persistent, resistant to simplification. Decades of effort had not reduced the number of particles or parameters. The standard model contained dozens of measure parameters. Attempts to embed it in simpler theories produced even more complex frameworks. Attempts to unify forces revealed entire families of particles. Efforts to explain constants introduced new assumptions. Even theories designed to eliminate parameters produced landscapes of possibilities instead. The more fundamental the model, the more options it allowed. String theory required 10 or 11 dimensions and produced astronomical numbers of possible vacuum states. Theories aiming for uniqueness discovered multiplicity. This buildup revealed an uncomfortable pattern. Simplicity emerged at large scales, not small ones. When many interactions averaged together, behavior smoothed out, laws became clean, predictions became reliable. But zoom in far enough, and the universe became crowded again. Gases obeyed simple laws only because they averaged over trillions of collisions. Solids exhibited regular properties only through collective atomic behavior. Simplicity was macroscopic, emerging when microscopic complexity was coarse-grained. This reversed a core intuition. The world looks complex because we see too much, not too little. At deeper levels, reality is not minimal. It is busy. Overlapping rules, competing influences, and conditional behavior coexist. The intuition had been that complexity came from ignorance, that seeing the fundamental level clearly would reveal simplicity. But the opposite was true. We see simplicity only when limited perspective blurs details into smooth averages. Emotionally, this was destabilizing. It suggested that there might be no final, elegant explanation waiting at the bottom. No single equation that neatly contains everything else. Understanding might mean navigation, not reduction. Science would not culminate in crystalline insight, but would continue mapping complexity, understanding how pieces fit together, navigating between levels of description. By this point, physics had to accept a new possibility. Simplicity is not a property of reality. It is a property of perspective. What feels simple depends on scale, context, and distance. A gas is simple when described by pressure and temperature. It is complex when described by molecular positions and velocities. Both descriptions are valid. Neither is more true. They operate at different scales. Reality itself is neither simple nor complex. Those are human categories. The universe was not hiding a clean core beneath complexity. Complexity was the core, and simplicity was something that only appeared when we stepped far enough away. This recognition did not diminish the value of simple descriptions. They remained useful, but it clarified their status. Simple laws were appropriate for certain contexts, not more fundamental than complex ones. The climax of this story is a quiet inversion. Simplicity was never the foundation of reality. It was a result of averaging over complexity. This reversal transforms how science understands its achievements. Simple laws are sophisticated summaries of complex dynamics. They work because they capture collective behavior systems with many degrees of freedom. Their power comes from effectively compressing information, not from revealing minimal foundations. Once this is accepted, physics stops searching for elegance as proof. Instead, it looks for consistency across layers. The universe does not owe us clean explanations. It offers reliable patterns that emerge when enough details blur together. The goal shifts from finding the simplest theory to finding theories that correctly describe reality at appropriate scales and connect properly across levels. This realization reshaped how scientists interpret laws. Fundamental does not mean simple. It means stable across contexts. Complexity is not a failure of understanding. It is something to be mapped, not eliminated. A fundamental theory works reliably in its domain, connects to other theories, and generates accurate predictions, not one that is minimally complex. More deeply, it reshaped humility. Human minds crave compression, short rules, elegant truths. But reality is not obligated to satisfy that preference. It functions whether or not it feels tidy. This recognition is liberating. It frees science from requiring that understanding be simple, allowing researchers to embrace complex explanations when nature demands them. Today, this insight echoes across science. From biology to cosmology, complexity appears not as noise, but as structure. The most reliable laws often describe averages, not details. Simplicity lives at the surface, not the core. Biological systems exhibit irreducible complexity at every scale. Cosmology reveals the universe's contents are more complex than imagined. Neuroscience finds simple behaviors emerge from intricate neural patterns. How simplicity turned out to be an illusion is not a story of disappointment. It is a story of maturity. Understanding does not always mean reducing. Sometimes it means accepting that the universe is richer than our desire for neatness. This maturity involves recognizing that science's power comes from building accurate descriptions, not finding minimal ones. And once that is understood, complexity stops feeling like a problem. It starts feeling like the point. The goal is understanding reality on its own terms. However elaborate, complexity allows the universe to be interesting, diverse, capable of producing rich phenomena. A truly simple universe would be sterile. The complexity that once frustrated physicists is revealed as the source of possibility itself. Simplicity was the illusion. Complexity is a reality. And embracing that reality is wisdom. How